Okay, so last concept with curve sketching is we're going to talk about inflection points and concavity, so concave up and concave down. Okay, so we are going to find, how do we find inflection points? Is we find the second derivative, set that equal to 0, solve for x, put that on a number line. If it's increase, it's concave up. If it's decrease, it's concave down. Okay, so very simple, very similar to what you would have done with critical numbers. So if we look at this example, to find my inflection points, I need the second derivative. So to find the second derivative, I need to find the first derivative. So it's the first derivative, second derivative. So I need to set it equal to 0. Solve for x. I'm going to factor out. Perfect. So x equals 0 and x equals 3/4 are my inflection points, or potential inflection points. So all I do is I put them on the number line, okay? And then I plug a number between -infinity and 0 in the second derivative, okay? Often I actually plug it in the factored form because I just find it's simpler. So if I plug -1 in there, that's going to be positive. -1 in here is going to be negative, so this is going to be negative, okay? And then when I plug a number between 0 and 3/4, so if I plug the half in, that's going to be positive. And if I plug a half in there, this is also going to be negative. So really important that you don't just assume it's going to do the pattern minus, plus, minus. Then I plug a number greater than 3/4, so I plug 10 in there. If I plug 10 in there, that's going to be a positive times a positive is going to be a positive, okay? So what I have is I have an interval of concave up from 3/4 to infinity, and I have an concave down from -infinity all the way to 3/4. You could write it like this, but it's or to 0, and then you could do 0 to 3/4, but it really means the same thing. You could do right either or. I wouldn't mark it wrong, but you can just go right ahead and just write the whole thing for concave down. So what would this look like graphically when you're drawing something like this is you actually are going to have an inflection point. That's another thing. To get the inflection point, take the x value of 3/4 and plug it in the original equation. So plug it right back into the original equation to get the y value. So this one would be -0.63.
Carter Bird, Liam Smalley, Brianna Baisley, Emma Shannon,
this is your inflection
George
point.
Cole,
That's where you have
Georgia
a
Case,
change.
and Brooklyn Sharp.
This
Please
is
come to the
concave
office.
down, and that is concave up. So basically, really exaggerated, this is concave down, and this is concave up. And where you change from concave down to concave up, that's what we call an inflection point.